Welcome back. Today we're going to do a little investigation to talk about describing quantitative data with numbers, and we're going to look at some summary statistics. So what's called a 5-number summary. This is a continuation of last video, and I've got some data here that we're going to work with to try to figure out what does it actually mean to describe this data. These are the heights of the AP students for our given class. And what I want to work you through is the process of finding these summary statistics by hand. As I alluded to last time, there's a way to do this on your calculator, but this is how you would do it if you had to do it by hand. So what they want us to do is they want us to find the median height. And to describe how you found that, obviously we're going to find the middle number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. So the 8th data point is going to be our middle one. 1, 2, 3, 4, 5, 6, 7, and 68 is our middle data point. Now, a lot of people are far more comfortable doing the cross-out method, so you could cross them out like this, right? And you'd come to the middle. Okay, you'd come to the middle, and you'd end up with 68 as your data value. Well, we can also do that mathematically, and that helps in a lot of ways, especially if we don't have necessarily in a small manageable number here. And so what is the median height? It's going to be 68. And what we can do is we can also label that as median. What about Q1 and Q3? So Q1 and Q3 are a little bit different depending on the number of data values that you have. Obviously, we have an odd number of data values. And so what I'm going to do is I am going to find the middle of this half of the data and this half of the data. When I do that, I've got 1, 2, 3, 4, 5, 6, 7 data points. So my 4th data point is going to be Q1. My 4th data point on this side is going to be Q3. What if you had an even number of data values? Well, the median so if the median is one of the values, meaning our median was one of the values, it was 68. If we had an even number of values, you'd take the middle two that you came to and you'd find the average of those, you'd find the mean of those. So if it's one of the values, so that would mean an odd number we do not include And what I mean by that is this. Notice where I drew my line here. So I drew my line. It does not include my median. So my lower half and my upper half don't include my median when it is one of the data points. So Q1 and Q3, Q1 was 63 and Q3 was 72. And I found those by finding the middle of my lower half and the middle of my upper half. So when we record these values, my minimum is 62, my Q1 is 63, my median was 68, Q3 was 72, and my maximum is 75. We're going to draw this in. I'm going to give you a general gist of how exactly it looks to draw what's called a box plot or a box and whisker plot. So my minimum is at 62, so I'll draw my line here at 62. Q1 is at 63, median is at 68, Q3 is at 72, maximum is at 75. Between Q1 and Q3, that's where my box goes, okay? So there's my box. And my whiskers reach out to my maximum and my minimum until we have an outlier calculation. We're going to talk about that in just a second. So to review, here's my Q1, here's my median, here's my Q3. Now what that means is we would call this the middle 50% of data. So the middle 50% of the data. In our case, notice that these are fairly symmetrical here. Okay, so this box is about the same size as this box. it always is going to represent the same amount of data. So there's 25% here, 25% here, 25% of data here, 25% of data here. If it's squishy, right? If one of the boxes is smaller, that just means that the amount of data is the same, but the data values are closer together. As we skip down to number 4, the interquartile range is defined as Q3 minus Q1. So for us to find our IQR, we would do 72 minus 63, which is equal to 9. So our IQR is equal to 9. That's consistent with what we find here when we go from 63 to 72. The IQR is the length of the box. Okay, IQR is the length of the box. The reason why we need IQRs is because that is what we're going to use to help us identify what is an outlier in a set of data. Before, we were talking about having an outlier be a potential outlier, right? So we have a data point that looks like it's farther away. Either it's a lot lower or it's a lot higher. Now that we have the outlier, we're going to have the outlier calculation. You can actually calculate and figure out, is it an outlier? So you don't necessarily have to just say there's a potential outlier. Here's how we do it. Potential outliers, high or low, can be called outliers technically using these rules. It's going to be way too small if I take 1.5 times the IQR and I am below Q1 by 1.5 IQR. What that means is, in my case, if my IQR is 9, 1.5 times my IQR is equal to 13.5. So if I extend down below Q1, 13.5 places, anything outside of that would be an outlier. Meaning I extend the arm down 13.5 places. Anything that's lower than 13.5 below 62 is going to be an outlier. On the other end, I'm going to do an arm that's 1.5 IQRs above Q3. So 1.5 IQRs above Q3. And anything above that, that is going to be an outlier. Hope that makes sense. So that 1.5 IQR gives me the length of that arm, as it were. I'm not going to draw that in. But in my mind, I should draw out an arm, and anything above that is going to be an outlier. So this brings us to our important ideas. Oh, wait, hold on. There's one more thing. I almost forgot. Outliers are going to be denoted by stars. So if I happen to have a value that is an outlier, I want to denote that with a star, and then my whisker is going to come to that data point that's above the lowest one that's an outlier. Important ideas. A 5-number summary for data looks like this. It's going to be inside braces. And inside the braces, I'm going to have my minimum, then Q1, then my median, then my Q3, and then my max. Those 5 numbers in that order. Outliers. Way too small outliers are going to be Q1 minus 1.5 times my IQR. And it's going to be anything less than that. So if it's less than Q1 minus 1.5 IQR, then that's going to be an outlier. Way too big. It's going to be anything that is bigger than Q3 plus 1.5 times my IQR. Let's do a check your understanding. You can go ahead and try this one on your own. We will come back together and talk about it. That's a good way to do these check your understandings. You can try it and then unpause the video and come back and see what you got for your answer. So the following box plots show the total income of 40 randomly chosen households, each from Connecticut, Maine, and Massachusetts, based on the U.S. Census data from the American Community Survey. Compare the distributions of annual incomes in the 3 states. So we're comparing. So that means we're going to have comparison words for that. For this, I am going to use my SOCV outline. So I need to talk about shape, outliers, center, and variability. Let's talk about shape first. So the distribution of income, that's my context. For Connecticut, check it out right here, it looks roughly symmetric. That's one of those LY words. While the other two, check them out. So they seem to be a little bit skewed, right? So a little bit skewed to the right, but one is stronger than the other. So we also need to draw that comparison. So while main incomes and the Massachusetts are stronger. That's a comparison word, skewed right. Okay, so I talked about all three. I drew some comparison words in there. Outliers. So check it out. What's really nice here is we can see that Maine and Massachusetts have outliers. Connecticut does not have any outliers. So we can say Maine and Massachusetts have high outliers, while Connecticut has none. What about center? What's a good measurement of center when we have box plots? Well, we've got our medians readily available. So what can we say about those? So the center, we can say high, middle, low, or high, highest, right? High, or highest. So Maine is lowest, and then Connecticut is second, and Massachusetts is third. So I'm going to say Maine has the lowest center, while Massachusetts is second. No, Connecticut is second. Second lowest. And Massachusetts is highest, or has the highest center. What about variability? Okay, variability. Let's see here. Which one has the highest variability? Well, Massachusetts obviously has the highest variability, right? Because they've got this really high point here, really low. And then it looks like Connecticut looks similar, right? So less than 150, less than 150. So what we can say, because we're just drawing a comparison, we could say that variability is highest for Massachusetts and similar for Connecticut and Maine. We outlined everything there. We have shape, center, outliers, variability for all three distributions there, meaning that we did our comparisons using our SOCV with context. We found out how to make a box plot from a 5-number summary and use data to find that 5-number summary. As a reminder, you can find all of these, the 5-number summary. So you can find the 5-number summary in your calculator. It's actually a fairly easy thing to do. If you put in your data, so you go to Stat Edit, and you put your data into L1. Then if you do Stat, this is after you get your data in, and then you do Stat and then Calc, and you do your 1 var stats, and this is on a TI 83, 84. If you do that, then that's going to spit out all of your summary statistics. So a 5-number summary, it's going to have standard deviation, it's going to have your total number of data values and all that kind of stuff. So That's a really useful function to learn on your calculator, to learn to do quickly, especially if you have a data set that's kind of unwieldy and you have a lot of different data points and you're trying to put them in order. That can be really tricky to try to find that median. That can really help you to use your calculator for that type of thing. So thanks for watching, guys, and we'll see you.